everyone. Thanks for joining us here today. As Molly said, I'm Liz Huttner-Loan. I work for Eric Klopfer's lab, the Scheller Teacher Education Program / the Education Arcade. So on the Scheller side, the lab offers a pathway of classes and also a student teaching practicum for MIT students interested in pursuing a Massachusetts state licensing certificate. And on the Education Arcade side, the lab explores playful learning. We have a lot of game-based projects. So that's just a little bit about our lab. So today I want to go ahead and talk about our approach to MOOC development, and MOOCs in general. I want to share a little bit of data regarding our forums, and I also want to take a closer look at one of our courses, 11.127x. I'll tell you more about what that is in just a few minutes. And I also would like to discuss groups as well. So groups are part of our forums. So in 2014 and 2015, our lab ran the EdTech X, the Educational Technology Program X series. So if you look, you'll see the various different courses. We started with the course on the design and development of educational technology, and then we eventually ended with the course on implementation and evaluation. So the final course of the series finished up in September of 2015. And we're currently in the process of rebooting the first one. So this is 11.132x, the design and development of educational technology. So the target audience for these courses is people who have all sorts of interest in edtech, so everyone from developers to teachers. 133x, the implementation and evaluation course, was particularly directed towards educators and teachers. So for our courses, rather than using lectures, we actually use interviews. So we interview various experts in the field. And our courses are very much influenced by the pedagogical approach, computer-supported collaborative learning. So we really care about our students collaborating and also learning together, pursuing lines of inquiry, that type of stuff. So these are the edX forums. These forums have several features. They do allow voting and favoriting, but it can be a bit challenging to see what's going on in the threads. So our courses actually don't use these forums. We use different forums. So these are our forums. These are the forums that we use for EdTech X. I just wanted to point out various features. We enable sort of better sorting. We do topic tags. It's easier to see kind of what content is fresher. And these are built on a WordPress template, but they've got a lot of back-end and front-end development by my colleague Paul Medlock-Walton, as well as others. So now let's take a look at what happened in the forums over the courses. So I've actually presented data from all 4 courses, and I wanted to call your attention to the forum users section of this. So while we had a certain amount of learners enroll in the courses, only a certain percentage actually logged into the forums. And you'll see on this page I also include some information about session duration and also the number of sessions as well. So one thing to point out is that for 126x, the forums actually weren't required. So that's why things look a little bit lower for that course. Okay. Let's see, and you'll also notice that 127x had the highest amount of forum users. That's important, and that's one reason why I'm going to take a closer look at 127x. So something to be aware of for our courses and also the forums in general is that all of our feedback happens there. We don't have any problems that are auto-graded for our courses. Instead, we have assignments, and we provide guidance for participants to grade each other, and not grade each other, and they're not assigning letter grades, but provide feedback, essentially. So let's go ahead and take a closer look at 127x. So just a reminder what 127x is. This is the Design and Development of Games for Learning course, and this is the course that had the highest number of forum users. Also, this course had 6 units, so it made it really easy for us to kind of look at checkpoints at Unit 1, Unit 3, and Unit 6. So in this course, learners explored the process of designing and developing educational games, including issues associated with assessment, implementation, and marketing. And for their project, they actually created a learning game. So some people created a digital learning game, while others created a more paper-based game. So this was our first time really taking a look at the forums and trying to kind of categorize the types of peer responses we saw. So we looked at the forums holistically, and when I say the forums, I'm saying we really spent the most time on the assignment forums where students were submitting work for feedback. And we noticed that there were three main types of responses. So prompt-driven responses. So the participant has made it really clear, that they are responding to the prompt that we gave them. They want to do what we told them to do. To helpful, constructive type of responses. So for these participants, maybe they didn't use the prompt that we gave them, but they, did really want to help the participant improve their work and provided some helpful feedback. And finally, we also noticed comment thought responses. So the participant, would generally be positive or negative about the other participant's work, but they wouldn't go much further. Sometimes they would give a story or provide some sort of reflection or anecdote. So there is a lot of work to be done regarding more descriptive categories, and especially for the comments section. And it's also important to note that these aren't the only types of posts that we saw in our forums. There were also other types of posts as well, but for the purposes of this project, we focused on the assignment forums. So I'll talk a little bit about methodology for this project. So we selected 3 assignments from 11127X, one in Unit 1, one at Unit 3, and one at Unit 6. And we only considered topics and posts submitted before the end of the course. Let me explain the topic versus post distinction. So when a participant posts their work on an assignment, that's a topic, but you may have several other participants respond. So there's both a topic and then responses of posts in that as well. So we wanted to take a sampling, so we basically used the equivalent of a coin flip to decide if a post was included in the project. And then we considered each post that was included as part of the sampling in terms of the types of peer responses that I've just explained to you, and then we coded accordingly. So let me tell you a little bit more about the assignments that we looked at for this. For Unit 1, the assignment we took a look at was the participants were told to pick a game and try to evaluate whether or not they thought it was a useful learning tool. Then for Unit 3, they were asked to create a prototype for their game with documentation about several items. Then for Unit 6, the assignment was basically finish up your project and reflect on the process. So we had a very small team of coders for this project, and it would be helpful to have more people kind of looking at these posts overall. So let me show you what an assignment prompt looks like. So for this assignment prompt, I've just excerpted the peer feedback guidelines. So as you see, we are providing them instructions and we're telling them what to do and how to do it, but we're not saying, use this exact rubric. It's more open-ended than that. Just give you a second to take a look at that. Okay. Great, so now you're probably wondering, what are these posts actually like in real life? And I'm actually gonna help show you what these categories look like by showing you some sample posts from the 127X forums. So these are real posts from our forums, but we have made some edits for readability and also to protect the names of the innocent as well, and perhaps the guilty, I'm not sure. So this is an example of a prompt-driven post. As you'll see, because you saw the prompt just a second ago, the participant used kind of language that we used in the prompt, and they addressed it based on the guidelines that we gave them. So it wasn't always as clear and easy to tell if the post that we were looking at was prompt-driven. This person did a great job of letting us know, hey, I followed the prompt, but some of them just weren't as clear. So the next one I'd like to take a look at is helpful constructive. So in this post, now this is from a different assignment. I did sort of pull posts from throughout the forums. This participant is clearly trying to help the other participant improve their game, but this particular post is not really tied to any prompt that we gave them. So, and for helpful constructive posts, there were definitely different kinds. We had participants, focus more on learning objectives or classroom applications, technical issues and mechanics. These posts could vary depending on the background of the participant commenting, for example. Finally, this is an example of a comment and thought. Now, I don't want you to come away with the idea that comments and thoughts are negative. Some of these, were very heartfelt reflections, but they weren't always as useful for a participant who's really trying to improve their project. So I wanted to take a look at peer responses across the 3 assignments and call your attention to a few things. So we thought that in Unit 1, since participants were just starting out, that we would see a lot more of these comment thought type responses. And that did turn out to be the case of the ones included in this little project. The other thing that we thought is we'd also find a lot more miscategorized posts. Maybe that participants had just posted randomly in assignment forums. And to be honest, that really wasn't the case. Most of the topics and posts that we saw in the assignment forum were tied to the particular assignment. You will notice, looking at the slide overall, that the number of prompt-driven responses is actually pretty low. So there's a couple of reasons why we think that's the case. One, our prompts are pretty open-ended. If we used a more rubric-driven approach, I think that we would perhaps see a higher rate of prompt-driven responses. And we also didn't require that participants formally structure their responses in terms of the prompts. We say, consider this as you respond. So I'd like to talk about another area of our forums now, which are groups. As part of our WordPress-driven forums, we also give participants the opportunity to collaborate with other participants in groups. And this functionality was first implemented in 127X, and then we also used it in our next course in the series, 133X. That's the implementation evaluation course. So participants have the opportunity to participate in 2 types of groups. The first one is affinity group. So any participant can create an affinity group. It could be about homeschooling, or perhaps teachers in Sao Paulo. Those are examples of titles. And then for the survey-based group, they basically fill out a survey that asks them questions about availability and also ability in certain areas, and they are randomly put into a group. And I just wanted to ask the audience quick. So I've given you 2 kinds of groups. Which type of group do you think was more popular with participants? Who says affinity groups? Raise your hands. Okay. What about survey-based working groups? Interesting. Okay. So I would like to report, I'm going to move on to the next slide here, that unfortunately our survey-based working groups were overall not as popular and also not as successful. I wish I could say these groups that were created by these surveys, they had very productive working relationships, but that hasn't been the case as we've observed. These groups sometimes would start out with a few intro posts here and there, like, hello, my name is so-and-so, I'm a math teacher in Wisconsin, that sort of thing. But these groups didn't tend to continue for longer than really these introductions. While we had some affinity groups that were much more productive, where participants shared coursework together, they shared interests, they shared resources, that sort of stuff. So I just wanted to let you know a little bit more about some of our more popular affinity groups. So for 127X, the games development and higher education had the most members, but our math games group in that course had the most posts. That was a very active group. So and these affinity groups really did generate some interesting connections and also some on-site meetups as well. So on our current course, which is the reboot of 132X, we are still running these groups, but we're trying to encourage the use of them more effectively. So I've got several community TAs that I'm working with, and they've all adopted affinity groups in several cases to try to see if we can encourage more group activity. Let's see. So I just wanted to end this talk by thanking Professor Klopfer and also 2 of our team members who have worked a lot on our course forums, which are so important and essential for our course's success. It's Paul Medlock-Walton and also Orit Geguzinski as well. So thank you very much. Yeah, sure, of course. Jolyon.
You told me you wanted me to use a mic. So it sounded like your prompt-driven responses was a categorization for like the first post in a thread, whereas the other ones sounded like responses to a thread.
I apologize. Perhaps I didn't explain it as well as I could have. So the prompt-driven responses were still in response to a topic. So basically, our participant would say, all right, here's my response to assignment 1.1, and then we'd have participants give that participant feedback. And sometimes those participants gave feedback in a way that was prompt-driven, and other times they responded in different ways. Does that help clear it up?
Okay, yeah, that makes more sense.
Great.
So in those statistics that you were showing, you didn't count any of the, here is my first initial post on what I've done.
No,
You were just looking at the responses to
Well, we did only in the fact that, like, if the initial post was counted, that we considered the response below it. Do you know what I mean? But it wasn't counted, it wasn't categorized as any of those three things because it wasn't a response per se. I mean, it was a response to the assignment, but not a pure response.
So does this mean that there were some people who posted to say, here's what I've done, and they got crickets?
Actually, it's a good question. We did find that most people did receive some peer response. It wasn't always of the best quality. I can't say, everyone got one great quality response, but most participants did receive a response from a peer.
Oh, thank you.
Yeah.
Someone else? I have a question for you.
Sure.
It sounds like what you're looking for really is to get a lot of peer learning because there must so many responses and postings that you couldn't sort of sift through them yourself. Is that true? And what's the quality of the peer learning between the participants? would you
So
say?
let me make sure I understand the question, because when you say the quality of peer learning, what do you mean, are you looking at learning participants as a whole? I'm sorry, I'm a little confused about what you're asking.
Well, I'm probably confused myself.
That's okay.
Did you notice that comments or anything that was any input was actually helpful, seemed visibly helpful to people in the class among each other?
Yes, I would say that there were a lot of helpful, constructive responses. Yes, I mean, there's, at least from what I've observed, there's a real impetus between the participants to help each other. So they understand that this is the only way people get feedback. There's no auto-grading. You're not going to hear about your work from one of the core staff members. This is your shot to get feedback.
That makes sense.
Yeah.
I think it's interesting that the affinity groups worked better. I mean, something we're trying to teal for, because we read some research about sort of group dynamics, and at the beginning of the semester we had like 600 students, and we were trying to match them based on like 7 parameters sort of thing. And one year we just told them to reorganize themselves, and it worked way much better.
Okay.
According to what the faculty thought. And I also was talking to some people that were trying to do an online teacher training program. And one thing that they noticed is that the online interaction was not that great until they actually met in person. And somehow, like once they sort of, I guess that you have to go through a team building process, and once you get over that, it becomes much easier to do the online interaction. Like, I don't know if you feel that that's part of it. I mean, the matching process has to be a little bit more personal, which is something that's much easier to do in person rather than to sort of crunch some numbers or get some data to it.
Yeah, I wish we had the opportunity, and this is a MOOC, so we've got participants from all over the place, to have more in-person meetings. I think you're right that we would be more successful. Though I should mention that there have been in-person meetings that have spawned based on affinity group activity. That has happened a few times. I don't know how many times, but more than once. So, I think you're right. Is that the fact that people are joining these groups because they're like, wow, I have this interest too. I want to share with my fellow participants. That's an important impulse.
Thank you so much, Liz. I think maybe we should move on.
Great.
Go to our next speaker, but thank you so much. I really appreciate that.
Thank you.
Just to let you folks know what's coming later.
I'm going to try and stand so I can actually see my slides. My name's Jolyon Bloomfield. I work in the physics department and also the concourse program here at MIT, and I've mainly taught the freshman physics courses. At MIT we call them 801 and 802. These are our classical mechanics and our electromagnetism classes. And I'll talk a little bit more about those as we get to them. What I want to talk to you about today is how technology is finally reaching a turning point where pieces are starting to click together in a way that we can actually use them in the classroom. And I want to start by inviting you to let your imagination go wild. If you could think of some way to use technology, don't worry about implementation details. If you could find some way to use technology in your classroom, what would you do? How would you exploit it? What could you build? I'll give you a couple of seconds to think on that. What amazing things could you make if you were able to just build something and use it?
So I've seen it online already, but a hoverboard.
Okay, you'll have to tell me afterwards how a hoverboard is going to increase the learning of your students, but I'll take it as a given.
Okay, so I would build some magical, amazing app that would read my participants' responses in the form and give them amazing feedback.
Exactly.
Pertinent, useful, great.
Exactly. And something like that is actually within the realm of possibility today. The natural language parsing and the essay reading, computerized learning stuff is at the stage where we can do that type of thing. But it's not available to us yet. I did a quick brainstorm of things that I thought that maybe I could do in the next couple of years if I set my mind to it. Maybe we could really improve instant response and feedback interacting with students. Maybe we could really get a really good hint system happening. Oh, you could do online environment as well. I'm thinking about in a classroom because that's where I want to implement technology. But a lot of this will apply equally well to an online system. It's meaningful that Dave just talked because my next point is to bring up a Socratic tutor, which Dave pioneered with the Mastering Physics program. Can we really improve classroom monitoring within a classroom to help give the instructor real-time feedback on how their students are doing, how they're performing? And I think the most pie in the sky of these would be some way of automating in-class statistic gathering and correlations to understand how your teaching is impacting your students and improving your teaching from that and improving your students' learning. All of these things are things that really should be within the realm of possibility, given the technology that we have available to us. But there's an underlying feature behind why we're not all using these in our classrooms today. And to me, that feature is that we're educators, we're not technologists. We don't know how to bring the tools together to implement these within our classroom. We're trying to do the best we can to educate our students, but there's some technological know-how that needs to go into each one of these. And the point I'd like to make in this talk is that we're finally getting to the stage where there is some scaffolding available to us, where we're almost at the point where we can start building these systems and we can start leveraging them to really improve our classroom teaching and beyond there, our online interactions with students. So I think there's 3 points that kind of go into this. The first is that we now have a plethora of internet-capable devices. Every student has multiple ways to access the internet, and this connectivity gives us opportunities that were just unthinkable 20, 25 years ago. We've got a ubiquity of instant response technology. We typically call these things clickers. We're starting to see them being used on phones and on computers and starting to reduce the tethering to an actual physical device. And the third point that we have, particularly in the last 5 years, is a learning management system that is reasonably flexible. I'm reasonably in brackets because some people might disagree with me on that, but it gives us a baseline to build upon. And we're starting to see people using this to come up with interesting things and interesting ways to improve their classroom experience. So, the classes that I'm involved with are the 801 and 802 physics classes. These are general institute requirements at MIT, so meaning that every student has to pass these courses or place out of them. They're mostly taken by the freshmen because they like getting the classes that they don't want to do out of the way quickly. And they range from 500 to 750 students. So these are very large classes. There's a lot of people taking these classes. These classes are taught using the TIL format, and in the past couple of years, we've heavily involved resources in developing the MITx platform to help run the 801 and 802 classes. And what I want to do for the remainder of this talk is to give you an idea of how we're starting to exploit technology to improve our presentation, our pedagogy, and the student experience, as well as the instructor experience within these classes. Let's start with the humble clicker. We use turning point clickers in our physics classrooms. There's other that are used across the MIT campus, and in 10 years, I think these might be going the way of the dodo. But for the moment, we're using them. They give us a way to tie a student to a response. Each one of these has a number associated with them, and we can track that number against a student. So we've actually got a lot of data here. We're just getting to the point where it might be good to start data mining these to find out how these are actually being useful. We like using clickers because they get students to think in the classroom. It's not sitting back and just listening to a lecture. It's getting students involved in thinking about their application of what they've been learning for the past 5 minutes and putting themselves out there and saying, I think the answer is this based on what I understood from what you've just told me. And by being able to get that feedback to instructors, we get a good idea of, did the students understand this, or have I completely missed the mark? Do we need to spend more time on this, or does everybody understand what we're doing? And it's really nice to teach like that. I quite enjoy it. The important part, as I alluded to earlier, was to get students to register with their clickers so that we know who is who in this data stream that we get back. So, here is the page where we ask students to register themselves. We sneakily scrape their Kerberos ID from their MIT certificates, and we just ask them for their clicker ID, we ask them which section they're in, and to make life easy, which table do you usually sit at, and which group are you in at that table, so we can really pinpoint where the students are. Once we've got a list of who the students are, and once they've registered and we know where they're sitting, we can go and create a class list for each class that we've got. So here's an example where I just pulled a snapshot of some tables and some groups in our classroom. I'd like you to compare this to what we get from the registrar's office, which is an alphabetically sorted list of 750 students, which is somewhat less than useful. Here we can give lists to the TAs, to the instructors for that classroom, and say, at that table, here's the pictures of the people that are sitting there and their names. And I found this useful for learning the students' names at least. I hope others are as well. Once we get clicker data coming in, we need to be able to deal with it in some fashion. The turning point clickers give us an XML file with a lot of erroneous data that we don't really care about, like how many milliseconds did it take since I opened the question for the students to click in? I really don't care, but it's there. We need to process the data in some way. And we've got a fairly rudimentary processing system at the moment where we're basically just storing all of the data that we get in from the clickers, and, well, we've got it for posterity, and if somebody wants to data mine it, please come and talk to me. But we can also use it for, well, we're basically using it for participation at the moment. But what we thought would be really neat would be to take in this clickstream data and get it to communicate with a learning management system like MITx and say, in class today, you saw these concept questions. Here are the answers that you gave. And this is how it compares to the answers that that we thought were the correct answers, and tying in their learning experience beyond the classroom and helping them revise once they leave. Haven't gone there yet, but I think that would be awesome. Another aspect of of using the edX platform to improve our teaching in the classroom is to try and improve the way that we get students to do experiments in the class. In the past, we get students to work in their groups of 3 at a table, and we give them a big sheet of paper with some instructions on it, and we ask them to write down some numbers on it that they've measured. And who knows if they actually know what the numbers are, or what they're supposed to mean, or if they're even in the right ballpark. So what we wanted to do was to move these experiments into the online platform to be able to take advantage of the instant feedback that the edX platform allows. The first thing we needed to do was to leverage this platform away from a single user experience into a true group experience. So we ask which students are working in this group at this table, who's doing the experiment today. Sure, we've got some data on students, tables and groups from when they registered, but who knows what actually happens once they sit down in a classroom. I highlight the word group here because edX is not particularly kind to working in groups, but we get along. In terms of the instant feedback part of our experiments, students can type in their answers. They can get told whether their answer is in the right ballpark or not. Are they plus or minus 50% on what they should have, or are they really a long way away? So for example here, somebody said that a nice red laser had a wavelength of, I don't know, what is this? A few microns, well into the microwave regime. And we can tell them, wait, no, stop. Something's wrong. Go back and check that calculation again. Make sure that you've understood it. In particular, check your units. Without this instant feedback, we'd get these stack of papers back at the end of the experiment. We'd put a little cross next to that number and say, check your units, give it back to the students, and well, if they actually see it, that would be quite amazing. The other thing that we get to do is to step back from the student perspective and look at the instructor perspective. When we've got computers talking to each other, when we've got a learning management system that's working, we can start generating these bird's eye view of our classroom. So this is a map of our teal classroom. Each square here corresponds to a group of students working at a computer on an experiment. And the squares are coloured by their progress through the experiment. So I can take a quick look at the screen and see who's where. Furthermore, if there's a group that's struggling, I can click on that. I can bring up the students in that list. I can see their photos and identify Sally, Bob, and Harry need my help. I'm going to go and help them through whatever they're stuck on at the moment. This is a, let me get this playing. I can get it playing. There we go. This is a real-time, well, not quite real-time. This is an accelerated map, a movie of what it looks like to see a class move through an experiment. Here, 1 second corresponds to 1 minute of real-time. And we can really see how the class is progressing. And you can see there's a class, one up there just turned from red. This one probably needs a little bit more assistance, so I should go and help them out. And it means that when we get to the end of the class, we don't say, right, has everybody finished? And somebody says, I just started, we got stuck. And so a lot of instructors really like this, this ability to look at their classroom and really see what's going on. Okay, so a few conclusions. We currently live in a technological utopia, but leveraging that technology to improve our classroom experience is kind of hard. And the main reason it's kind of hard is that we need to get a whole lot of different technical systems to communicate with each other. The technology to do what we want to do, apart from hoverboards, has been around for quite a while. You could have thought of most of the things that we're starting to do now 15 years ago when the internet started becoming really popular. But we're only just starting to see them happening now. And I think there's 2 main reasons that we're starting to see them happening now. The first is that the scaffolding to build these systems has only really started coming online in the past few years. And on top of that, we're educators, we're not technologists. We need not only scaffolding to be in place to build these things, what we really want to see is for there to be a product that we can take off the shelf and plug into our classroom and have it work straight away without having to use some do-it-yourself system that requires somebody that knows what they're doing to bring all the bits together. But as more and more scaffolding comes into place, hopefully we'll see more and more systems that we can string together and really use to influence and better our classroom teaching and our online experience as well. So, with thanks to a bunch of people and most of ODL. Thank you. Sorry? Oh, by all means.
So I'm a technology person, educational technology person, actually. And I find myself wondering if you as an educator saying you just want the technology would be willing to be a participant in the design of the technology that would actually work well for you, rather than sort of being given something that's not maybe quite what you want.
I think most of the educators can come up with some imaginative view of something that would be great if we could do it in the classroom, and we just have no idea how to implement it. And in my experience, I've had very limited interaction with educational technologists, such as yourself, and I think it would be an amazing opportunity to sit down and talk with you and say, wouldn't it be great if we could do this? And let our imagination run wild and let your sense of, well, here's what might be possible, hold us back a little bit and see whether we can meet in the middle somewhere.
I think that would be great. I don't know how things are actually working at the moment with kind of the new tools and the new organizations, but I hope that that will be a priority to really get that relationship going again.
I think that would be great. And I think I speak for most of the room in saying that we'd love to see this as well.
Actually, I can comment on that comment in two ways. One is, I think a lot of people who are actively teaching do not have a lot of time to do something other than actively teaching. So they're more likely to provide feedback than aid in the design from the beginning. I mean, based on my experience, it is much easier to have something that works at some level to make you think about, all right, what do I really need? Because if you just start from absolutely nothing, it's very, very difficult to think about how these different, so, you know, for example, we had the MIT X tool, and then suddenly decided, hey, you can do the experiments this way. And how would that improve the experiments? I also wanted to comment, because you talked about the real-time feedback on the experiments, and that just sort of helps you identify what groups are doing bad, well, or poorly. But with the clickers, when you're getting real-time feedback on the clickers, I can be there in class and have the whole class is discussing. I can watch the relative votes of different options go up and down. I can give them hints as they're discussing it. I can say, okay, we have votes for two options, roughly equal, one of them's wrong. So half the people at the table you're sitting at think you're wrong, and that can guide the discussion. And I think that kind of thing, you know, when we thought about clickers, okay, you know, you can see what they understand or not. Now you realize, well, you can do much more than that if you have a little better technology.
That's a really good point, George. But as you said, now that we've got something in place, this clicker technology, it's something that we can think of building on. Wouldn't it be great if we could use the clickers and have this map of the classroom and see that table over there has it all wrong. I need my attention over there. The table over here has everything all right. Get them talking, but they don't need attention quite now. We don't quite have the technology in place to do that, but it's a stepping stone. It's something that we can see and something that might be able to work towards.
I agree with you. And I think even just closing that feedback loop and having people involved and sort of coming back and saying, this is working well for me, this is not working well for me. And the other thing that I want to add about clickers is, and I hope we'll hear from Jennifer and company too, that I'd like to see richer sorts of interactions than just clickers with students handwriting things, getting that automatically interpreted, because the technology is there. I confess I'm an AI person, and so I build that kind of thing. So I know that it's possible to actually expand on the kinds of questions that you can get your students to answer, so that it's not simply clicker answers, things that are already provided. But and I think that there is definitely work going on now in trying to expand the kinds of questions that you can actually get answers to in real time, and automatic scoring and that kind of thing, and suggestions to both teachers and students.
Anybody else? Going once? All right, thank you so much, Jolyon. That was really great.
Just close it.
Done.
Excellent.
So I'm Jennifer French. I work in the math department, and I have been involved with a lot of residential projects, but the thing that I'm going to talk about now is a project that we started for our calculus class that we actually released first as a MOOC and are only now using residentially for the first time.
Yep, so I'm Martin Segado. I'm a graduate student in mechanical engineering. I got into online education through TAing actually for mechanical engineering courses that were released as MOOCs, and worked with Jen last year to help develop the sketching tool for this calculus course.
When we decided to make calculus as a MOOC, the biggest issue that we had was that sketching was a really big part of our objectives for students in a calculus course. There's a lot that goes on. We want them to understand the mathematical language and the symbols. We want them to understand how these are represented as curves and functions in the plane, and we want them to understand the physical meaning behind them and to be able to move fluently between all these things. And so we really wanted students to be able to enter sketches into, just draw them into the platform, because otherwise we felt like we actually could not teach calculus at all. And there's also a lot of research that supports this. We know that expert problem solvers frequently use sketches in many, many fields all over science. Oh, no.
Oh.
It was fine for a second, and then, no, it was never fine.
Might have been the,
I'm going to just take this thing off.
yep, that's a good idea.
Even this page is missing the left-hand side.
Oh.
Try hitting present again, see if it works.
Let's see if I can first make it. We tested it on my computer first, I'd like to point out.
There we go.
Oh,
Yeah,
Yep.
that's better.
that is indeed better. Lovely. Yeah, indeed.
And the other thing, so the other reason we wanted them to actually generate sketches is that we know that this is actually a higher cognitive skill to generate something and to construct something yourself versus recognizing other people's sketches through something like multiple choice. And ETS has actually done a lot of research showing that actually there are skills that cannot be adequately measured using multiple choice. And we really believe that sketching is one of them. The other issue is that we really wanted to be able to automatically grade sketches. And this obviously was important for our online students, but it was also important for us thinking about our residential students here on campus. And one of the reasons is that typically these are graded on paper, they're submitted, there's a delay in the feedback that the student gets. If they even look at that feedback, it may not be very detailed. And whereas with the automatically graded sketches, we can provide immediate targeted feedback on where the sketch is going wrong, and we can give them multiple attempts so that they can actually correct their mistakes and get it right, which is ultimately what we want. We want them to get it right, and we want them to figure out where their mistakes are and fix it right away. I'll just give you a brief demo of what the tool looks like. You see that it has these plug-in tools at the top, like a function, a vertical line asymptote, a horizontal asymptote, and various points, and that you can drop them all in and sketch. There's some automatic smoothing that happens in 2 different levels. First, it smooths a bit just as you're drawing, and then it actually smooths the final result by fitting everything to cubic splines, which are what we actually use. That's what we pass to our grader to do the analysis for the grading.
Okay. So, of course, you guys aren't here to see bullet points, I'm sure. Pretty pictures are much nicer. So we actually deployed and ran this in a course, which finished back in December.
No, so we ran it in the first course that ran over the summer. It started in June, but we actually started with a prototype of the tool, and about halfway through, launched the version that you just saw, and then that course ended in August. And then we have a second course that is running right now. Actually, it was supposed to be over today, but due to an edX timer bug, we extended the deadline to tomorrow. So it'll be over very soon. And we used the sketching tool there as well.
Yep. So the results that we have over here are from some of the problems that we ran in the first of those 2 courses. We deployed a total of 13 different problems using the newest version of the sketching tool. We had 870 odd learners interact with this in some non-trivial way, so submitting an actual graph. This is not including the course staff as well. And over the 13 problems, they actually generated a total of just over 8,000 graphs. About 89% of them were correct by the last attempt. That varied depending on the particular problem, but overall, people seem to be getting these right, which is encouraging. And people seem to be getting them right in a reasonable number of attempts, typically. So generally, we saw 2 or 3 attempts for people to get them correct. Here you can see the actual distribution of number of attempts for the different problems. So along the top row and the second row, we have some of the practice problems that we gave them, or exercises, as well as some of the homework problems. The blue bars on the right of each of these graphs are students, or the distribution for students who eventually got the problem correct. The much smaller red bars on the left are the distributions for the students who never got the problem correct. So you can see overall, most people eventually got it correct. A lot of people got most of these correct in a single attempt, which is really wonderful. Some of the problems were considerably harder. So, for example, this problem, you'll notice very few people got it correct on the first attempt. A lot of people got it on the second. Several people lasted longer, and these poor souls up here apparently submitted 10 or more tries before they got it correct, which is really quite impressive. Another conspicuous feature here is you'll notice there are no attempts above 5 for the final. This is because we didn't limit the number of attempts for most of the problems, but we did limit them to 5 attempts for the final. So you notice also for the final, there is a much higher fraction of incorrect submissions because we had that limit on the number of attempts and because the stakes were considerably higher. And also the people who did eventually get it wrong used up all of their attempts, as you can see. Can look at the average attempt distributions for exercises and homeworks as well. And this shows more or less the same picture as the other ones. Typically, students would get this correct in somewhere between 1 and 3 attempts. There's a bit of a long tail up here with some students taking 7, 8, 9, 10 or more attempts to get it correct, but eventually getting it correct. And on the incorrect side, we actually see a similar pattern. So a lot of students tried it once and then gave up. Several students tried it a few times, and the numbers dwindle as you go higher up. And again, we have a few poor frustrated folks at the very top who tried 10 or more times before finally giving up and not getting the answer. Thankfully, the proportion is quite small, although it would be ideal to improve that in the future. Here's the corresponding picture for the final exam. In this case, most students got it correct probably within the first couple of attempts. Most students who never got it correct used up all of their attempts, which is pretty much what you would expect. There were still some students who just tried once even on the final and then gave up, or twice and then gave up, which is interesting, but they're a fairly small percentage. Promised pretty figures, so here are some pretty figures. Since we do have quite a few submissions for each problem, one of the interesting things that we can do is simply overlay them, give each submission itself some translucency, and then we can kind of look at the aggregate to see if there are any patterns there. This is one of the easier problems where we're asking them to draw a quartic function, I believe. You can see there are some things that are fairly tightly constrained, so a lot of people will get the critical point location here exactly at x equals 1 or very close to it. And then there are other things that pedagogically we simply don't care about. We don't care about the exact position of the tails of their function. All we care about is that it's generally going up. There are also much more complex problems that we gave them. This is one of the harder ones that we asked them to draw, and yet still a significant chunk of our users were able to eventually get the correct submission, as you can see. So in this case, we have multiple asymptotes, both vertical and horizontal. We have critical points around here. We have inflection points as well. And then the function itself that goes between all of these. So this one you can go for because it's kind of an interesting, unexpected result that we saw.
So one of the things, some of these problems, there's a grid here because we graded them on a grid, but a lot of the problems we actually are just grading qualitatively. So we didn't give the students axes to see necessarily, although there was a grid.
Yeah. Nor did we expect exact numerical results for some of these. We just wanted the general shape.
So, maybe I missed it, but what's correct?
All of these are correct
No.
that we're showing.
No, okay.
Pedagogically, you mean what's correct?
No, I mean,
What were you looking for?
you're not showing the incorrect ones.
Oh, we will.
Well,
What makes them correct?
oh, I see. Each of these has its own associated grading script. The scripts look for different things depending on the problem. Typically, we're checking for the location of critical points. We're checking for the number and position of asymptotes. We're checking the slopes of the function in different region. Occasionally, we're checking if the function passes through a particular point. And very occasionally, we also check curvature.
Yeah. So in this problem, we're checking things like where is it increasing, where is it decreasing, especially with respect to things like the asymptotes and with respect to the labeled critical point. And so that's actually the important feature, is that once the student labels a point as being critical, that is actually essential to our grading script because we grade with respect to that labeled point. And
The student labels points being critical, so each student gets to label what they consider critical?
yes, and those are those dots that you actually see here. This is the point that the student labeled as critical.
Yeah. The advantage of that is that it lets us ask qualitative questions. So we can ask them to draw the general or to sketch the general shape.
It's just not a trivial problem to grade those things at all.
It is not.
Yeah, there's,
But actually, we find that having them drop the point makes it easier in many ways. That's part of why we did, that's why we have the multiple tools, is that we find that just grading something as, is this asymptoting, like, that's essentially impossible. It's very, like, these actually all look pretty nice, but, you know, you could grade something, you could draw something like this over here, and that's technically asymptoting to the correct things. And so it's much better if they just tell you, that's my asymptote. And so that's what we chose to do. But the interesting thing about this is that you actually see that by and large, when people chose where to drop their critical points, you see a lot of people choose along grid points, which is something that you would expect. If you're going to pick a random point, why not pick something on a grid? Except then you have this one random point.
and this is a concentration of points, which is why it's showing up brighter.
So in these problems, this was early on in our release. We had just released the tool. And so we actually gave them 100 attempts, and we allowed them to see the answer whenever they wanted. So you may guess this, but this is where we placed it in our solution.
So anyway, this was an interesting feature. It seems that there's a good chunk of people who were just looking at the solution and exactly copying it.
Yes.
Where people could have multiple accounts.
Yeah, when we first released the new version of the tool, and that it was halfway through the course, we were a little bit hesitant to put too much weight in it and put too much emphasis on the grading, and so that's why we allowed students to be able to see it and just cheat, basically, because we were like, give us feedback. If you have a correct answer and it's wrong, we need to know about it. We're going to make improvements. We'll fix it in real time. Tell us. And I mean, all of the edits that we made to the grader were from people being like, hey, my solution is not right. What's wrong about it? And actually, I could go a couple slides back. Here you see an artifact. I don't know if you can see it. There's a faint line right here. And this is from a change I made in the grader script to reduce my restriction on counting the number of asymptotes, because it turned out that on some computers, when they dropped an asymptote, it was actually dropping 2 and right over each other, and so I couldn't count them the way that I wanted to, and we fixed that bug, but this grader had an artifact where I had not then gone back and fixed it, and also I don't like to take away points after I give them, because I'm soft like that. But
yeah. So you had asked about some of the incorrect answers. The incorrect answers.
Could you give us the question?
Certainly. So there were a few questions, I think. Do you mean the question that's up here?
How did you ask that?
How did you ask this one? So I suppose we can, if we have a few minutes at the end, we can pull up the actual page.
There are a couple different ways that we would ask questions. Basically, they had 3 formats. Either, here's the formula for a function, sketch the derivative.
Mm-hmm.
Or, here is the function's derivative and second derivative, sketch the function. Or, here is a sketch of the function, sketch its derivative. And these, I think, this one in particular was, here's the function and its derivative, and sketch it. This was early on, so we were really nice to them. We did all the hard work for them.
Yeah. We can pull up, if people are interested afterwards, we can pull up some of the live MOOC content after this talk and show you what it's like. So incorrect submissions. In general, these plot much less cleanly than the correct submissions. Some of them are all over the place. It helps somewhat to sort them or to categorize them by the feedback that we gave. So in this case, we're showing all of the incorrect submissions for one of the final problems, where we gave the feedback, what is the relationship of your function to the horizontal asymptote? So in this case, you can see there's a clear conceptual error that students had over on the left-hand side of the graph. Where all of these students continued their function above the asymptote instead of asymptoting from underneath, which is the correct response. There was another one which showed some fairly clear clustering. Here we gave the feedback, check the location of your horizontal asymptote. And while there are a few that are kind of scattered throughout, like up at +2 and -1, there was a significant cluster of students who submitted as an incorrect answer an asymptote at 0. So we can get some interesting information about misconceptions. In general, this is much harder, though, to look at than the correct submissions. So one of the things that we hope to do in the future is look at perhaps some machine learning clustering techniques to see if we can extract some of these features.
And then we also want to rewrite our grading scripts in order to make sure that we're giving the right feedback at the right time based on the correct misconception.
Mm-hmm. So a few future directions. One of them I just mentioned is looking at some clustering analysis of the data. Another thing that we are thinking of doing is looking at automation for the grading scripts. So currently, the different criteria that we're checking The instructor specifies through a Python script and can go through several conditions where they say, make sure the graph is increasing in this location, give this feedback if not. Make sure there's a critical point here, give this feedback if not. However, for a lot of classes of problems, such as rational functions in calculus, it might be a lot more convenient to simply have a semi-automated grader which we can feed a function and tell it to check for slopes, curvatures, and asymptotes, and simply have it generate all of the criteria necessary. Mechanical engineering, which is my department, there are a lot of possibilities for this as well. For example, we could have beam problems where the instructor feeds in a beam with particular forces, and the grader criteria are automatically generated for an axial force diagram, for example. Eventually, this opens up a really exciting possibility, which is to automatically generate randomized sketch problems. So for mechanical engineering, again, we might have a beam and simply drop forces on it at random with random magnitudes and directions and have the student sketch the graph in response. And this is great not only for things like preventing cheating in MOOCs, but it's also absolutely wonderful for students because they now have unlimited practice problems in a particular class of problem. So that's a very exciting possibility. There are a few things that we want to do with the tool itself. One of them is work on keyboard accessibility and accessible drawing tools in general. Using the mouse or touch or pen input seems to be working fairly well for a lot of our users, but there are users who simply will not be able to do that due to mobility impairments or vision impairment. So that's something that we hope to improve. And then finally, the ultimate plan for this is hopefully within the next few months or so.
Better be.
Yeah, to open source it and disseminate it. So we have folks at a few different universities who are interested in using this, and if any of you all are, please let us know. So, thank you very much. If you have questions, please feel free to email us, grab us after this talk. Jen has a website up with a live demo of this tool if you want to go and try to sketch a rational function. Use Wolfram Alpha. If you can't figure it out, that is perfectly fine.
We can take a question. Yes.
So you mentioned three types of problems you'd ask. Here's a function, sketch its derivative, or types of things. One of the issues I've found repeatedly in my freshman physics courses is that students have trouble sketching a function given that function. Is there a reason that you...
Oh, we do that too.
Oh, you do that as well? Okay.
Yeah. Actually, the final exam problem that you saw, one of the final exam problems where they had the incorrect behavior of the asymptotes, let's just go back to it. This actually was a sketch this function problem. And we had several of those as well, though not in the other data that you saw. And so the issue was exactly that they didn't understand the behavior as it went towards negative infinity.
Can you grade things like the integral or the derivative of the function that they produced?
Yeah, we don't have that data here because it was a bit confusing to look at, but that's actually one of the problems that we had was actually sketch the derivative and the second derivative, and we can grade it all together.
So depending on the problem, we might ask for that explicitly.
If you,
Oh.
if they drew a figure, the problem might be write a sketch of the acceleration such that at the end the velocity is so. So you're really asking, you want to grade the integral of the curve that they submit.
Oh yeah, we can do that.
Yeah.
Especially
Well,
if you give it an initial value, or like a point to go through. That makes it even easier.
Well, yeah, and it's also maybe much harder to make a derivative grader because that increases instabilities.
So actually, I
I
think
think
at
it's
the
the
moment,
I think
at the moment the one that we're doing is the derivative, the slope grading. So.
Oh yeah, well we are grading. You mean what the grader is doing, or what? I think
what the grader's doing, I think.
Oh, okay.
Um,
Yeah, no, we're looking at slopes. We are looking at the derivative
But
mostly.
the data is there to look at the integral too if we wanted to.
Because what we're actually passing as the data is a collection of splines, cubic splines that we actually have all the information about that we know everything about the splines.
Would it be possible to do implicit function plotting, like x squared plus y squared equals 1?
Working on that right now as I'm making some polar graphing problems. It is possible.
Thank you so much, Jennifer and Martin. That was really cool. Thank you.